happens, but solid waste materials or the components of solid waste are going to be getting segregated depending upon the weight of the waste, right? Depending upon the weight of the waste. If the weight is heavy, because of the gravity, it is going to be falling at the point where it is going to be discharged, right? Similarly, in the other method where a rotor is used, which is going to be generating the air stream. Because of air stream, depending upon the intensity, the materials, the solid waste components are going to be falling depending upon their weight. If it is going to be heavier in weight, it is going to be falling closer to the rotor. If it is lighter in weight, so the distance traveled is going to be large, or it is going to be falling at a large distance from the given location. These are the two methods how we are going to be using the separation technique. The next method what we are supposed to deal is with respect to the flotation method, right? Floating means what? Any component which is flowing on the surface of the surface of a liquid. That's what I'm telling, right? It is on the surface of a liquid. So those floating techniques we are going to be using, wherein which we are going to be segregating the material which is lighter in weight. Of course, we know that whether you might, if you have gone with the sedimentation and all in a GT and GT, what happens if a water is made to stagnate, right? What happens? Let us say this is a container, and if you have let the water to stagnate over here, the heavier materials are going to be settling down, and the lighter materials are going to be floating on the surfaces. By using these techniques, we are going to be removing the material which are going to be lighter in the weight. That's what we are going to be uh, using over here. That is our floating technique. So in floating technique, uh, the purpose of doing this one is that if you have if it has a glass rich material and all, then only the removal of what you call it as material is going to be taking place, right? So this is applied for a composite, again for a composite material, wherein which you have uh, a large component, wherein which you have a large component whose compositions are going to be a glass rich feedstock. See, where you get specially this one, it do again depends upon how the characteristics property of your solid waste is gonna be, right? It means to say that in a location, right, in a location or in an area where you are gonna be having a capacity, or where you are gonna be having the capacity of solid waste, wherein which you have a large amount of glass rich feedstock. See, glass rich feedstock means it might not be only glass, it might be any product or any waste which is going to be generated from the glass. It might be glassware, it might be glass used in the kitchen, a bottles which is used for packing, a soda bottles, or any type of glass, or either it might be optical glasses also. So those are going to be used, so which are going to be very heavy. Like, why we are not going to be using in other method is that because the screening, when if you are doing with the heavy fraction, it is not easily going to be separating, right? These materials are not going to be easily getting separated, whether if you are going to be doing screening. If you do screening, what happens? See, in a screening, you have seen that a screener is going to be laid on some angle at some inclination of 5 to 15 degree. So in a screening, when it is going to be rotating, while rotating, there is going to be always chance that these materials are going to be getting crushed further. So to avoid that one, we are not going to be using this one. Then what happens? Again, if you are using in a air, what you call it as a your air blow separation system, again it is heavy enough so that it cannot be removed off, and also it doesn't have any what you call as ferrous metal property, so that it is going to be separated easily. So what we do in this technique, what we call it as a floating technique, the glass rich feedback which is produced by screening of heavy fractions of air classified waste, or material which are going to be separated from a ferrous metal segregation, that is what we are magnetic segregation. These are going to be immersed in a soluble tank. That soluble tank might be consist of any material, right? It might be consist of any material. So what happens, depending on the intensity of the weight of the material, heavy material is going to be getting settled down. See, I'm telling a soluble water in a soluble tank. So immersed in a water, it might not be a potable water. It can be any water, even if it is having a rainwater, which can be used for this purposes. Or if you have a wastewater or a water from a garages and all, this can be used over here. Again, their purification is not going to be an important, right? So what happens over here? The heavier materials are going to be settled out, and whereas the lighter material which are going to be floating are going to be removed off. As I told you earlier, if this is a tank, right, which is going to be having a water, let us say you have a water until this point, right? Until this point you have a water. So what you do? You submerge the waste over here, right? Whatever the waste is there, that is going to be submerged over here. So depending upon the intensity of the waste, the heavier materials are going to be settled down, whereas the lighter materials are going to be floating. Then the lighter materials are going to be removed from this tank, right? Then in this again you have different types and methods. That is one what we call it as optical sorting. Optical sorting again is referred to glass. So it is used mostly to separate the glass waste from the waste stream. You are going to be taking the glasses separately. This can be accompanied by identification of a compressed air blast and removing the glass separately, which are going to be plain in color or which are going to be in the colored format. So in optical sorting, see, once you have done a floating technique, as I told you, the heavier material are going to be settling down, the lighter material are going to be floating. So once you take this lighter material outside the tank, you're going to be going for the sorting method. In sorting, you go first with the optical sorting. In optical sorting, you're only removing the glass waste from the streams. These glass waste are going to be removed. See, if the intensity of or if the capacity of tank is more, automatically when you have the small pieces of the glass and all, those can be easily floated upon the surfaces. Then you have the other materials which are going to be having a transparent properties of the glass. Like if we have oblique materials which might not see glass, which is not only referred to a plain glass, it might be a glass which are going to be obtained from ceramic materials, bottle caps, which all are in the streams. Those are supposed to be removed up in the optical sorting. Then this do involves your drying and what you call it as dewatering system. Again, this drying and dewatering technique, which are supposed to take in detail in next module. So we will not go in detail process. So what we do in drying and dewatering, we only take the what you call it as the highlight of this one. Drying and dewatering means what? If let us say, as I told you, a glass might be consisting or a waste of a glass might be consisting of a oil supplement, or it might have been used to for a oil packaging system or some beverage system or some system which are still attached to the surface of the system. So at that time, either you will go with a drying or dewatering system. It is if it is considering a consisting of any adhesed material or adhesed liquid, then you go for drying. Or if it is combined with some impurities or some what you call it as waste which is going to be attached, then you go for dewatering, wherein which by pressurizing the water you are going to be removing the waste which is going to be attached to the glass. These are used for what you call it as operation in primarily for incineration and all system, with and without again a material recovery system. Either dewatering and what you call it as drying process you are going to be using primarily in a what you call it as incineration system, because again if a glass, let us consider that it is some glass waste you have over here. Let us say this is some part of a glass waste you have, right? If this waste is coated with some waste, right, some liquid waste or some waste of oil, so what happens if you take it for incineration? That what happens, this waste which is going to be coating, it might not be helping in what you call it incineration system. So it required more time and more fuel and more energy. So we are going to be doing first dewatering and drying system before we process this waste in an incineration or for any recycle and recovery process. This is also used for drying of sludge in wastewater treatment plant prior to incineration system, or to transport to that land disposal system. Of course, all the sanitary waste which you have, waste from toilets and bathrooms, or waste from the what do you call it as poultry farms or some animal yards and all, those waste which is going to be having some sludge, before we take to the treatment system, we are going to be going with the drying and dewatering system. The purpose of this one is only to remove the moisture away. and to make it a better fuel. That is what in the I'm only giving the highlight. The detail we are going to be seeing in the next module, right? So the only purpose is to remove the moisture from the waste and to make it better for the what you call it as better for burning system, right? Light fractions, in a dry format, they are going to be using as easier to transportation and prior to incineration for energy recovery. If depending upon the dimension of the glass particles, we are going to be using this one, right? Okay. Then you have convection drying. This is nothing but a method in which you are going to be blowing a hot air, which is going to be coming directly in contact with the wet waste, which is going to be leading to drying the waste. Then you have conduction driving. In this method, the wet solid waste is coming in contact with the heated surfaces, because of which the moisture which is present in the waste is going to be getting evaporated. In the convection system, you are going to be blowing the air. In this conduction system, you are going to be applying the heat or on the surfaces, like we have a conveyor belt which is going to be having a temperature or which is going to be heated or with some temperature. The waste is going to be thrown on this belt. When it is going to be traveling, during this traveling point, all the moisture which is present in the waste is going to be getting evaporated. Whereas in a convection system, in a area or in a place where you have stored your waste, where we are going to be blowing with the jet of hot airs, because of which the water is going to be getting evaporated. So these are what your convection and conduction system which you are going to be doing. Then you have a radiation system. In this, heat is directly transmitted on the wet waste by radiation or from the heated bodies, or by simply placing them upon any surfaces wherein which the heat can directly be transported over there, because of which, or you are going to be heating the waste in a what you call container, or you are going to be heating this container so that heat is directly transmitted when the waste comes in contact with the surfaces, and the removal of what you call it as water or the moisture from the waste is going to be taking place. So this is all what we have with respect to the component segregation. Remember, component segregation really plays a very important role. As I'm repeatedly telling, if the segregation of the material is not proper, if it has different parts and different components, if the segregation of any substance which can be having some recyclable value and reusable value, if this is not separated before you're going to be going for disposal process, or if you're not providing any disposal purpose, let us say it is a sanitary waste only, let us say you have a sludge over here. If the sludge is going to be directly taken to the digester, that is biogas digester, or without being given a prior separation, if you have taken this one, this sludge might not decompose properly. Or if you're using this sludge for burning, if you have a cow dung, if the cow dung is wet, we are not going to be using that for burning until and unless the cow dung cakes are going to be dried off. That's what we are going to be doing in separation, component segregation. We are going to be applying all the techniques so that the